A new one today, which is water. Okay, this is the first new one. There are 2 H's and 1 oxygen in water. Hydrogen has 1 valence electron if you look at a table, and oxygen has 6. This also adds to 8. Now, we need to see that oxygen is going to be in the middle because H can never be. I've placed 2 bonds here, 2, 4. I have 4 electrons shown, okay? And so I need to show 4 more because 4 plus 4 equals 8. So I'm going to put a pair up here and a pair down here, okay? And that is what H2O looks like, all right? So those are the first 3. This one's going to get a little bit more difficult just because the number's a little bit larger, okay? SiF4. Every single one we did yesterday and so far today have all equaled 8. This one, as you will see, does not equal 8. There's 1 Si and there's 4 Fs in this molecule, okay? Si is in group 14 with carbon, so it's 4, and fluorine is in group 17, so it's 7. So this adds to a pretty large number, which is 32, okay? So you need to look at this molecule, and you need to figure out what goes in the middle, okay? Almost always, when you have multiple of one element and one of another element, the one element's going to go in the middle because you can't determine which fluorine gets the special treatment of being put in the middle, okay? The real rule is to figure out what is the least electronegative element, and that goes in the middle. Well, fluorine is the most electronegative element we have, so it cannot go in the middle. So we're going to put Si in the middle, okay? And we've got 4 fluorines. We need to connect it on all 4 sides to fluorine, okay? So we're going to do that. Now, if you look here, I need 32. I only am connected to 8. 2, 4, 6, 8, okay? You need to make sure, I didn't mention this in this video, but I did yesterday. Let me turn that light back on real quick. Either in person, if you watched it in person, or saw it in person, or you watched the video, that every element needs 8 around it except for hydrogen. And we can see carbon has 2, 4, 6, 8 around it. Nitrogen has 2, 4, 6, 8 around it. Oxygen has 2, 4, 6, 8 around it. Silicon has 2, 4, 6, 8 around it, so it doesn't need any more. But these fluorines do. They need 8 electrons around each fluorine. Okay, so this is how you would make one look like. And then you can kind of see if that one's going to look like that, then they all are going to look like that. All right. So if you were to count this, you get 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. And that's what SiF4 looks like, okay? A little bit more going on there than these, I realize that, but you just got to make sure everything except hydrogen has 8. So kind of the same deal here. There's 1 N, 3 Cl's in this compound, as you can see. This is 5 and this is 7, okay? So this adds to 5 and this adds to 21. That's going to take us to 26. Now, we have 1 N and 3 Cl's, okay? So, fun fact, nitrogen and chlorine actually both have the same electronegativity. So if you were to, look at a periodic table here, and if you have this one, the electronegativity is shown right here, if you didn't know that. Okay, but still, the one that has 3 cannot go in the middle. It's the N. So we're going to put the N in the middle. We're going to attach it on 3 sides to chlorine like this, okay? Now, you have to make sure everything gets 8 around it. So we're going to add dots around everything to make sure every single element here has 8 because there's no hydrogens present. So around nitrogen, we have 2, 4, 6 because each line represents 2. So we need 2 more. That's going to give nitrogen 8. For chlorine, each one has 2, so we need to add 6 more. That's 2, 4, 6. Same thing here. 2, 4, 6, 8. 2, 4, 6, 8. Now we need to count and make sure that this is correct. This adds to 26. 2, 4, 6, 8. 10, 12, 14, 16, 18, 20, 22, 24, 26. It does, so we're good, okay? So that is how you would draw the Lewis structure for NCl3. These are all single bonds. That's why it's labeled as simple molecules, okay? We only did single bonds yesterday, all right? And we only did neutral molecules. We're about to do polyatomic ions. Poly in anything means multiple. This means multiple atoms for these ions here, okay? As you can see, for PO4 negative 3, there's 5 different atoms. Well, there's 5 total atoms. There's 2 different ones, phosphorus and oxygen, but there are 5 total if you add the 1 and the 4 here, okay? So we're probably not going to do all of these that you see here, just a couple, because this is sort of new today. This should be a review from yesterday. These will be a little bit new, but this is something that we're going to be doing next week, so it's good to see. All right. So for PO4 negative 3, we start the same way. So over here, okay, I kind of goofed that up. Hopefully I give myself enough room, because I definitely didn't give myself enough room over there. There's 1 phosphorus and 4 oxygens, okay? So that's just the quantity. There are 5 valence electrons in phosphorus. It's in group 15. You should be seeing that. If you look at a periodic table in oxygen, there are 6. So this adds to 5, and this adds to 24. Now this adds to 29. If you watched what I talked about yesterday, you would have known that I told you that these numbers need to be even, because you're adding pairs here. Everything's in a pair. It's not one electron by itself, it's a pair. So the number 29 is obviously an odd number. So we actually have an extra step when solving for an ion, okay? You see this charge right here? This charge for this one is negative 3. We're talking about electrons here. You're adding the total number of valence electrons, okay? So when you have a negatively charged polyatomic ion, which is most polyatomic ions are negative, not all, but almost all of them are, you're going to add the charge to it. So 29 plus 3 equals 32, which is an even number, okay? So here you have 4 oxygens and 1 phosphorus. Well, we don't want to give an oxygen a special treatment and put it in the middle. We want to put phosphorus in the middle, okay? So we're going to connect it on all 4 sides to oxygen. Now keep in mind, we need to show 32 electrons, okay? So far, I've connected it on 4 sides, 2, 4, 6, 8. 8 is not 32. So these oxygens, just like up here, they need to have 8 around them. So we're going to add that in the form of pairs of dots, okay? Until all of these have 8. And then we need to count and see if we are doing it correctly, if it adds to 32. So let's do that. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. It does add to the 32. Okay, so this is correct. Now, an extra step you must take when doing an ion here, the proper method is to put it in brackets and then to put its charge, which is negative 3, on the outside. That's just the way it's done, okay? So for this ion, that's what you would need to do here, all right? So we're going to do one more ion, and then we're going to move on to these multiple bonds, and then we'll be done, okay? So that's called phosphate, okay? This is called chlorate. So we're going to do the same thing, Cl and O, just like we did yesterday. 1 Cl and then 3 O's. Chlorine is in group 17, so it has 7. Oxygen is in group 16, so it has 6. That adds to 7, and this adds to 18, which then gives us 25. Well, we need to have an even number. So just like here, that's negative 3. This one's negative 1, so we're going to add 1. That gives us 26, which is an even number. Okay, so we're good. There are 3 oxygens and 1 chlorine. So with that, with you seeing that right there, you need to put chlorine in the middle. So we're going to do that. Attach it on all 3 sides to oxygen. okay? And we're going to give everything around it 8, just like we had done over here. So this has 6 right now because it's connected to 3. We need to show 20 more. So give everything enough to get 8. Each of these oxygens needed 6 more because they already had 2. This chlorine has 2, 4, 6, so it needs 2 more. Let's add this and make sure it's 26. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. We are good. And our last step, since this is a polyatomic ion, and you know that because it's multiple atoms and it has a charge, you need to put its charge in brackets right there, okay? So we're not going to worry about these 2 today. Don't want to make this video too long, so we're just going to focus on these 2. We will be doing this next week, within the first couple days of the week. So, all right, we are going to do these 2, and then that'll be it for here. These are multiple bonds. So this involves what we call double bonds and maybe even triple bonds. We'll see. We have single bonds. Every bond you've seen so far is a single bond because it's one line that connects 2 separate atoms right here, okay? So every line you've seen so far is a single bond. That's about to change, okay? So there's a process of doing this, which we will talk definitely more about next week, but at least to get an intro today, let me show you how you do it. So everything starts the same. There are 3 elements here, different ones, CH and O, as you can see. Carbon has 1, hydrogen has 2, and oxygen has 1. This has 4 valence electrons, this has 1, and this has 6. At this point, you should be able to figure that out with relative ease. Or if not, you're pretty far behind, and you'll need to get caught up. 1 times 4 is 4, 2 times 1 is 2, so 4 plus 2 is 6, and then 1 times 6 is 6, so that adds to 12. We have to show 12 electrons, okay? That's a small number compared to the ones we just did, okay? Now, here's drawing this structure, admittedly, is definitely, in my opinion, harder than any one we've done so far, okay? So hydrogen can never be in the middle. That's the first hint. Carbon is always in the middle. That's the second hint. Carbon is the least electronegative element of these 3 other than hydrogen, which hydrogen can't be in the middle, okay? So we're going to place carbon in the middle. Okay, we're going to connect it over here with an H. We're going to connect it over here with an H, okay? Now, we're also, because we cannot connect an oxygen to an H, because H cannot be in the middle of anything. It only is connected to one different element. We're going to put O down here, okay? Now, remember, you need to give everything 8, okay? So let's do that, except for hydrogen, of course. Hydrogen is already good. You need to give carbon 8. It has 6. It needs 2 more, okay? Good. And oxygen has 2, so it needs 6 more. Now, we look at this and we count how many valence electrons we have in this molecule. We need 12. We have 2, 4, 6, 8, 10, 12, 14. So we have 14, but we need 12. Okay. When you have more than what you need, you have to make what's called a double or a triple bond here, okay? And in the notes, you will see next week when we talk about it, when you have 2 more electrons than what you need, you have to make a double bond, okay? So essentially, the math you're doing here is you're going to be subtracting 4 electrons and adding 2. And let me show you what that looks like. We're going to make a double bond in between these 2, okay? And the reason it has to be here is because we can't make a double bond between hydrogens because they can only hold a maximum of 2 electrons. So it has to be here. So what we're going to do is we're going to take off this pair of dots, okay? And we're going to take off, it doesn't matter which pair of dots here, but I'm just going to take this pair off. So I've erased essentially 4, okay? 4 electrons and 2 pairs. Now I'm at 10. So I can draw another bond in between carbon and oxygen. And if I do that, carbon has 2, 4, 6, 8 around it. It's happy. Hydrogens are already happy. Oxygen now has 2, 4, 6, 8. It's also happy. In total, we have 2, 4, 6, 8, 10, 12. So remember I said we're going to subtract 4 to add 2. Okay, so we get 12. This is the double bond. This is a structure that has a double bond. Okay, so hopefully this is at least a decent intro. Of course, I don't expect you to become a pro at this after this video, of course, but this is a good start for next week. The last one we're going to do in this one is HCN. Okay, so for HCN, there's one H, one C, one N, as you can see. This is 1, this is 4, and this is 5. You add these up, this adds to 10. As 1 plus 4 plus 5 is 10. Okay. Now, hydrogen is never in the middle. Carbon is always in the middle. So with that being said, we're going to make it look like this because look, we can't connect the H to the N because H is only connected to one element, so it has to look like this. You've shown 4, you need to get to 10, but you have to give everything 8, okay? So to do that, carbon needs 4 more. So essentially, when you follow the steps of doing this, you're actually going to draw it wrong first sometimes when you make these double and triple bonds, and you're going to have to go back and correct it like I did here. Nitrogen needs 6 more because it only has 2. So if you count here, 2, 4, 6, 8, 10, 12, 14. Okay, we have 14, but we need 10. All right. When you have 4 more, last problem we had 2 more than what we needed. When you have 4 more than what you need, which is the case here because 14 minus 10 is 4, you either can make 2 double bonds or 1 triple bond. And we can't actually make 2 double bonds right here in this problem because H, as you see, cannot ever have a double bond with it. It can only have a singular bond right here. It can only be connected to one atom right here. So you can't make a double bond here. That means you have to make a triple bond right here. So we're going to do that, we're going to erase this pair, and we're going to erase this pair. Okay, and when we do that, we can add a line. So we're taking 4 away again and adding 2. So now we're at 12, but we still need to get to 10. So for this last pair right here, okay, these last 2. Take this one away, take this one away, minus 4, 8. We're going to add 1 more, okay, which gets us to 10. So this, without these markouts here, this is what this molecule looks like, okay, HCN, cyanic acid. All right, so this is a good intro to a little bit more difficult